Delaware Tech, Chem 100, Chem 110, Unit 1 continued, problem solving, strategy, and use of conversion factors. So whenever we have a problem, the first thing you need to do is identify the unknown, both what type of quantity, is it length, is it time, is it mass, is it density, volume, etc., and the unit that you need to have that answer in. So if it's mass, does the questioner want the answer in grams or in kilograms, for instance? Or if it's a distance, should it be in meters or millimeters or kilometers? So you need to know both. The second thing to do is start writing down the known quantities that are in the question. Make a table if there are a lot of them. If you have a pressure and a volume, for instance, of a gas, and a temperature of the gas, make a table of each of those values. Say the pressure equals this many Pascal, or the volume equals this many liters. And that way you have it all there to look for when you're creating the problem answer. Plan a solution. How do you plan a solution? Well, if you know it's going to take multiple steps, plan a solution where you start with quantities you know. For instance, you have the mass of something. Ask yourself, what can I turn the mass into? And then ask yourself, what is being asked at the end? Maybe it's density. Maybe it's the number of particles that we're talking about. And you can ask yourself, okay, I know what I need to end with. What do I need to get to that end? And then you can work backwards from the answer as well as forward from the unknown, from the knowns. And therefore, you'll end up with a pathway that links the things you know to things you need to calculate first, to the things you finally will calculate in the answer, the unknown that you desire. So each step in that pathway that you created will either be a conversion factor, and we'll talk about what those are, or a whole separate formula. So you need to find or create your own conversion factors or formula in many cases. Now you have a table of formulas that you're given in the handout set, and you're given a table of conversion factors. Quite a large table of conversion factors is one of your handouts as well. You can always refer to that list. So in addition to that list, the periodic table is filled with numbers that can, under the right circumstances, be used as conversion factors. There are other conversion factors also on your handout. You can find them online if they're not there, but most of the ones you need, maybe even all the ones you need, are already in your handouts, or they'll be given to you in the problem itself. And sometimes plain old common sense will tell you what the formula is or what the factor is. For instance, you know that there are 60 seconds in a minute, therefore your conversion factor is 60 seconds per 1 minute, or 1 minute per 60 seconds. You need to find your correct formula. You're given a table of formulas, and some you may have to generate yourself. So write down the formula, then solve for the unknown variable without even putting the numbers in. A lot of people like to put the numbers in right away without solving for the unknown that they want. For example, what if you had a problem where you know the formula says A equals B divided by C, and you were asked to determine what C is or what B is, not what A is. And maybe you were given the other two values. So let's say you were asked what B was, and you were given C and you were given A. Well, this is the thing you need to solve for first. So rearrange your equation. You can move the C that was on the bottom on the right to being on the top on the left. Now remember, if a number is by itself, it's already on the top. So you can convert this formula to A times C, and you could write a little dot in there to show times, or you don't have to if it's just variables. And that will equal B. So now you know the correct formula, the final formula, and now you merely input the values you were given for A and the values you were given for B, and calculate, values for C, and then you will calculate B directly with your calculator. So then you put in the numbers after you've created the correct formula, the finalized version of your formula. Once you've calculated, check, recheck, and maybe even recheck again, because people have problems typing in numbers on small buttons of calculators. That happens all the time. I have that problem happen all the time. So you always want to recalculate on your calculator and make sure you got the same answer twice. If you didn't, do it a third time. Once you are convinced you have the right number, and maybe you're still not sure, first make sure that you take the number that the calculator gave you and round it to the appropriate number of sig figs. And we've already talked about the rules for doing that with multiplying, dividing, and the rules for doing that with addition or subtraction. Make sure you have the right unit. If the question asked for kilograms, don't give grams. If the answer was asked for joules, for instance, a unit of energy, don't give kilocalories. Does the answer make sense? And a lot of times you can look at the answer and say, does this make any sense to me? I got an incredibly small number. Should I have gotten an incredibly small number? Or I got a number that's only a little bit larger than my original number. Does that make sense? There are lots of questions you can ask to check. And if it doesn't, make sure your formula is right. Make sure you input the correct numbers. Always go back and make sure your numbers in your table were copied correctly from the original problem. A lot of people miscopy numbers. It's very easy when there are a lot of digits. So once you have your strategy, you can use tools like conversion factors to actually solve your problem. So what are conversion factors? Well, conversion factors are disguised versions of 1. All right, what does that mean? Well, we know that 1 foot equals 12 inches. In fact, we know that 1 foot is exactly equal to 12 inches, and this is what's known as an equality statement or a statement of equality. 1 foot is the same thing as 12 inches or equivalent in some way. And we know that the thing on the left is exactly equal to the thing on the right. That's what makes it an equality statement. Now, if I divide both of these sides of this statement by, say, 1 foot, so I divide this by 1 foot, and I divide this by 1 foot, well, we know that 1 foot by 1 foot is just 1, and therefore we know that 12 inches divided by 1 foot is also equal to 1. And if I had instead divided both sides of this equality statement by 12 inches, I would get this other fraction, 1 foot over 12 inches, also equals 1. And these are called conversion factors, and they are disguised versions of 1. And if you want to convince yourself that these really are 1, remember, anytime you have a fraction where the numerator, the top of the fraction, equals the denominator, the bottom of the fraction, well, if the top equals the bottom, then the fraction must be equal to 1. So these are both equal to 1. Now, conversion factors within the same system, like metric to metric or imperial to imperial, or SI to SI, tend to be defined quantities. 1 kilometer, 1 kilometer, equals 1,000 meters. And in fact, we know that because the prefix tells us so. Kilo means 1,000, and you probably heard somebody say, I made 50K last year. Well, that means they made $50,000 last year. The kilo literally, the K stands for kilo, and the kilo literally means thousands, in this case dollars. Well, in this statement shown on the slide, kilo is 1,000, and you can literally take the phrase 1 kilometer and substitute the word 1,000 for the word kilo and have an equivalent meaning. 1 kilometer, 1 kilometer, equals 1,000 meters. And that is automatically your equality statement, which can easily be turned into 2 conversion factors. 1 kilometer over 1,000 meters, or 1,000 meters over 1 kilometer. And these types of conversion factors, the ones shown here, happen to be ones that are exact. And when they're exact, they have infinite sig figs, infinite significant digits, significant figures, whatever way you want to call it. But the important part here is anytime you have an equality statement, or you're creating some kind of conversion factor, or you've done a conversion of one thing to another thing, you will always see the exact same pattern. The larger number will always be linked with the smaller unit, and the smaller number will always be linked with the larger unit. If those two are not connected, you probably made a mistake somewhere in your calculation. For example, 1,000 millimeters equals 1 meter. Okay, milli means 1,000th. A lot of English-speaking students think milli means millionth because it sounds so much like the word million. Please do not confuse these two. Micro actually is millionth in this nomenclature. Milli means 1,000. So 1,000 millimeters is literally saying 1,000 thousandths of a meter is 1 meter, which makes sense. If you have 1,000 thousandths, that's the same as 1. Think of a pie sliced into 1,000 pieces. They're each 1,000th of the pie, and if you had all 1,000, well, that would be one whole pie. So 1,000 millimeters is equal to 1 meter. And you'll notice the larger number, 1,000, is associated with the smaller unit, millimeter. It's much smaller than a meter. It's 1,000th of a meter. And the smaller number, 1, is associated with the bigger unit, meter. And you'll always see this pattern. Small number with the large unit, large number with the small unit. So, as I already stated, conversion factors are disguised versions of 1. And that's because they're made from equality statements where you divide one side by the other. So the top always equals the bottom or is equivalent to the bottom in some way in your fraction. 1,000 milliliters, so now we're talking about volume, equals 1 liter. That becomes 1,000 milliliters over 1 liter, or 1 liter over 1,000 milliliters. 1 inch equals 2.54 centimeters. So now this is a conversion between an imperial unit, inch, or you can call them English unit, but it's properly called imperial unit, to a metric unit, centimeter. Centimeter is 100th of a meter, centi meaning 100th, just like there are 100 cents in a dollar. So 2.54 centimeters is exactly equal to 1 inch. So this was actually a defined value. It was actually defined to define the inch in terms of the metric system. So this can become 1 inch divided by 2.54 centimeters, or 2.54 centimeters over 1 inch. Those are conversion factors that are exact in this case and have infinite sig figs. The density of gold is about 19.3 grams per milliliter. Okay, what does this mean? Well, this is not an exact number. This is the best estimate people have given. It means that if I had 19.3 grams of gold, it would occupy 1 milliliter of volume. Likewise, if I had 1 milliliter of volume of gold, it would have a mass of 19.3 grams of gold. So anytime you see a fractional unit, grams per milliliter, meters per second, any of these can be instantly turned into a conversion factor. You'll notice 19.3 only has one number, but you can split this into 19.3 with the grams on one side of your dividing line and 1 milliliter on the other side of your dividing line to make these two conversion factors. And these would be useful to convert milliliters to grams or grams to milliliters. The speed of light is exactly 299,792,458 meters per second. This was actually defined as this value in 1982. We used to have lots of decimal places past the 8 in this number, but in 1982, the community that does the standards for the whole world said, okay, enough's enough. Let's just set it at exactly this whole number value, and we'll just slightly change the meter to match this whole number value. So now the speed of light is exactly this number. This has infinite significant digits. Even though it looks like 9 digits, it's actually infinite because the real number is 299,792,458.0000000 forever. So it's infinite significant digits, just like the 2.54 centimeters equals 1 inch. It's really 2.540000 forever, and 1,000.00000 forever milliliters equals 1.000 forever liters. All of those are exact. In fact, 19.3 grams per mil for the density of gold is the only non-exact conversion factor here. And you can do this kind of split of conversion anytime you see a unit of something divided, one unit divided by another unit. Conversion factors within the same system are almost always defined quantities. 12 inches equals a foot. 100 centimeters equals 1 meter. 1,000 millimeters equals 1 meter. 1,000 meters equals 1 kilometer. Another English system one would be 3 feet equals 1 yard. Those are all exact because they're within one system, imperial to imperial or metric to metric. Some measurements between imperial and metric are exact and defined, but some are just estimated. So all metric to metric are defined, and the reason why they're defined is because they're based on prefixes with exact defined definitions. Centi means 100th, milli means 1,000th, kilo means 1,000. And as a result, all metric to metric conversions have infinite sig figs. So why is that important to even mention that they have infinite sig figs? Well, the reason is this. When you're using conversion factors, you're multiplying them times some original quantity that you want to convert. And let's say your original quantity is 1.55 meters. So we have this quantity of 1.55 meters, and I'll write that here. 1.55 meters. Well, if we want to convert that to centimeters, well, we put meters on the bottom because that will cancel our old meters. We always put our units in first. And we want to create the unit centimeter. Sorry about that. Let's get rid of that. Centimeter. We want to create the unit centimeter. It's a little hard to write here. And then only after we put our units in the right place, because we know meters will cancel and we'll leave centimeters, then we put our numbers in. Centimeter is a smaller unit, meter is a larger unit, so we know our large number, 100, will go with the centimeter, the small unit, and our small number, 1, will go with our big unit, meter. And when we multiply this out, we get 155 centimeters. Now, you might look at this conversion factor and say, oh, well, each of those numbers only has one significant digit, then I need to round my answer to one significant digit, which would be 200 centimeters. Well, no, you don't do that. You never do that. Because this actually has infinite sig figs. And therefore, if I start with 3 significant digits, I better end with 3 significant digits. And that's the beauty of having exact conversion factors. If you have a less than exact conversion factor, like 19.3, whatever number you start with, no matter how precise it is, no matter how many sig figs you have at the end, you can never get better than 3 sig figs if you're using this conversion factor, because that's all it has. 19.3 is 3 sig figs. But each of these conversion factors has infinite sig figs, so if I start with 7 significant figures and multiply it by any one of these, I'll end with 7 significant figures. If I start with 2, I'll end with 2. So you'll end with the exact same number of sig figs as you started with in each case. And that's why it's important to have very good conversion factors, preferably perfect ones with infinite sig figs. But you always want one that has at least more sig figs than your actual number that you're converting, your quantity that you're converting to a new quantity. So always get good conversion factors for that. And remember, your equivalence statements, how you can check, I'm just saying this again, you always want to have a large number associated with a small unit and a small number associated with a large unit. And other sets of examples of that are 1,000 millimeters equals 1 meter. A millimeter is small, so we have a large number. We have 1.609344 kilometers equals 1 mile. This is actually exact. It looks like 7 digits, but it is infinite significant figures, because after that 344, it's zeros forever. And that equals 1 mile. And in fact, you see the larger number, the somewhat larger number is with kilometer, and the smaller number 1 is with miles. That's because the kilometer is a little smaller than a mile. In fact, it's about 6/10 of a mile. And then the last one, 1 million microliters. Micro, remember, this is the only prefix that has a Greek letter abbreviation. That's the Greek letter mu, which is the Greek alphabet's version of M. That means a millionth. So a million millionths of a liter is 1 liter. A million of this tiny unit equals 1 of this much larger unit. So they match together. So let's look at some examples of creating conversion factors. Now, conversion factors can be either these exact equivalences of quantity, length to length, time to time, volume to volume, mass to mass, or they can be equivalencies based on rates. For example, if I said 60 miles per hour, that we know 60 miles is the amount you've driven in 1 hour. Now, we know that 60 miles is not the same concept as 1 hour. One is distance and one is time. But there's an equivalency there based on that rate of 60 miles per 1 hour. So therefore, we can use rates as conversion factors as well as our standard conversion factors of exact quantity to quantity conversions. So the first example here, there are 5,280 feet in a mile. This is an exact conversion, by the way. And you won't always know this unless you're told that this is exact. So I will let you know when things are exact, or you'll see that there are so many significant figures anyway that it will not affect your answer. So we know that 5,280 feet equals 1 mile, and therefore we could divide one by the other or the other by the first to get two different conversion factors. But we can also have some unusual things like the statement, for every water we have 2 hydrogen atoms. Well, in that case, we know that there are 2 hydrogen atoms per 1 molecule of water, or 1 molecule of water per 2 hydrogen atoms, because they have a certain equivalency about them. One molecule of water has 2 hydrogen atoms. And I'm telling you this if you didn't already know it, but remember the formula for water is H2O. That means there are 2 H's, hydrogen, and 1 O. We don't usually write the 1. So here are the first 2 that I just mentioned, and here are the second 2 that I just mentioned. Now looking at C, this is a rate. 200 cars are produced each hour. In other words, the manufacturer is making cars, and 1 hour of work in this factory is equivalent to 200 cars being produced. So we could write this as 200 cars produced over 1 hour, or 1 hour over 200 cars produced. So it's a rate. We know that time and cars are not the same concept, they're not the same quantity, but there's an equivalency there because of this rate that we know. And if we look at this last one, water's heat capacity, and we'll talk about what heat capacity is later, is 4,184 joules of energy per 1,000 grams per 1 degree Celsius. Well, there are 2 pers here, so we divide twice. And when we divide twice, we really are just dividing by 1,000 grams, so 1,000 grams will be in the denominator on the bottom. But so will the degrees Celsius, because we're taking that number and dividing it also by a single degree Celsius. So in this case, we would create a conversion factor that initially looks like 4,184 joules divided by 1,000 grams, but also divided by 1 degree centigrade. Likewise, I can flip that and say that for 1,000 grams and 1 degree Celsius change, and we haven't learned what that means, but it's a change in temperature of 1 degree, we require 4,184 joules of energy. And this ratio, the first ratio that's shown here, is referred to as the specific heat of water. It tells you how hard it is to warm up water, how much heat you have to add to something in order to make the temperature go up. And I know in everyday English we use temperature and heat meaning the same, but in science they don't quite mean the same. So joules is a unit of energy, or heat in this case. Heat is a type of energy. And joules per degree gram would be the unit of specific heat in this case, which we'll talk about later. I noticed that there's a question mark next to the G in the final version. Unfortunately, that was a font conversion. It should say J over G degree, so it's joules over gram degree. So let's actually look at some examples here. The general equation is you start with the number of the old unit, and you want to get to the new number of the new unit on the right side. Well, when you create your conversion factor, if you start with your original unit by itself, well, in a fraction, that's the same as divided by 1. So the n number of the old unit on the left really is n number of old unit divided by 1. So that's really the numerator. It's the top. If it's only by itself, you consider it the top. And if you want to convert it, you have to make sure that the old unit that you're destroying is on the opposite side. So in this case, in the conversion factor, which is always shown in parentheses here, the old unit is on the bottom because the old unit will cancel the old unit that's shown on the left with the n number of old units. So you have n number of old units. The old unit will cancel with the old unit, but the n number and the y number will still be there. They will not be canceled. Just the units will be canceled. And the only unit you will have left is the new unit. So this is the type of format you want to make whenever you're doing a conversion from one unit to another. If you start with your old unit over here, you want to build a conversion factor, and you want to put your units in first. So let's say we had an example where we wanted to convert, let's say, kilometers, and we had 5.6 kilometers, and I'm not going to go through the whole problem here, but we wanted to convert kilometers on the bottom to miles on the top. And I've told you that, 1 mile is equal to 1.609 kilometers, approximately. Well, we can then see that the kilometers will cancel the kilometers, and the only unit we'll have left is the one that we wanted all along, miles. And MI is the appropriate abbreviation for miles, by the way. So you then would take 5.6, multiply it by the 1, and divide it by the 1.609. And of course, you don't have to actually multiply by the 1. We already know you'll get the same answer. But that is what happens. You multiply all the top numbers, which are these top numbers, and you divide by each of the bottom numbers. We only have one bottom number here, so you're only dividing by 1.69. But keep in mind, if you had, say, 5.6 and 1, and we were dividing it by 1.609, which is the same thing as what we're doing. I'm leaving out the units for a second here. And what if you also had to divide by 7, for instance? Well, when you're typing this in a calculator, you will multiply the 5.6 times the 1, if you had to multiply it by 1. You will then divide by the 1.609, and then you will also divide by the 7, because both of these numbers are being divided. Do not write times here, or you will get the wrong answer. Your calculator doesn't see this line. It has no idea that the 7 is below the line unless you tell it, divide that one too. So make sure you use your calculator properly when you're doing this. So, going on with the format here. So here's an example, 4 feet, and we want to convert it to inches. Well, we know that 12 inches equals 1 foot. We first build our conversion factor. And how do you build it? You start with a parentheses and a line. That's the first thing you should write. You know you have feet in the beginning and inches in the end, so feet should be opposite of the old feet, which is on the top here, so your feet should be on the bottom, so to speak. And inches are the unit you want to create, so you put that on the top. I highly, highly recommend when you build a conversion factor, do it in this order. Number 1, make your parentheses with a line. Number 2, put in the units. And only after you put the units in, put in your numbers. Do not put your numbers in first. It's a very easy way to make a lot of mistakes. So, here's an example. A student has entered a 10.0K run, a 10-kilometer run, 10.0 kilometer run. How long is this in miles? 1 mile equals 1.609 kilometers. Okay, well, we're going to take the thing we have. What is the thing we have? The thing we have is the 10 kilometers. Always start with that and start converting one step at a time. Do we have a way to go right from kilometers to miles? Well, yes, we do, because we have a conversion factor that directly converts kilometers and miles, or miles to kilometers, either way. And now we build our conversion factor. We start with our parenthesis and our line. We know we're starting with kilometers, so they're on the bottom. If this was on the top, we put 1 on the bottom. And we want miles in the end, so that's going to be on the top. And then we look at our conversion factor and say, oh, what's 1 mile? Okay, it's 1.609 kilometers. So it's an easy way to build your conversion factor without really risking making a mistake. Does this answer make sense? Well, look at it. We started with 10.0 kilometers, and we ended with 6.22 miles. Now, you'll notice I've already rounded this answer to 3 significant digits. We actually have more digits here, but I rounded it to 3 because we started with 3, and our conversion factor had 4. So our final answer should be the lesser of those 2 sig figs, which is 3, and therefore our answer is rounded to 6.22 miles. Now ask yourself, does it make sense? We know from the beginning that a mile is bigger than a kilometer. It's about 1.6 kilometers. It's a little more than a kilometer. So if we know that a kilometer is smaller, the kilometer unit is smaller than the mile, well, this many kilometers should equal less number of miles. And it's only a little bit less. We're going from 10 to roughly 6. Does that make sense? Well, yes, it does. So that's your check at the end to make sure that you've done your math right. And do we have the unit that we asked for? Yes, we do, miles. So everything worked out. It makes sense, and it has the correct unit, and it has the correct sig figs. So here are more examples for you. I'm not going to go through each example. You're given a conversion factor. It says how many gallons are in 8.7 liter jug. Well, we know we're given liters, so that's what you're going to start with. We know we're asked for gallons, and we have a conversion factor that in one step can convert gallons to liters. In fact, we know that a gallon is a little less than 4 liters. You might have heard that before. 4 liters is a little bit more than a gallon. So I'm going to pause. At this point, you can stop the video and see if you can work out the problem yourself. And then I'm going to show you the answer here. So we start with the number we have, 8.7 liters. We multiply it by a conversion factor that we created with liters on the bottom, gallons on the top, and we get our answer that the calculator tells us, and then we round it to the 2 sig figs that we started with. We start with 2 sig figs. Our conversion factor has 4, so 2 is the less of those 2. Our answer should have 2 sig figs. And it makes sense. The making sense part says, well, look at the gallon. The gallon is about 4 liters. Well, then 8 liters should be about 2 gallons, right? So, in fact, it's 2.3. Here's another one, but now we have something where we're asked how many miles per hour. We always write mph, but I highly recommend you convert that to miles, mi, over hour, hr. How many miles per hour are in 343 meters per second? So we're converting both the top unit and the bottom unit. So in this case, you have to do 2 conversions, one to convert the bottom unit and one to convert the top unit. So if we start with the thing we have, which is this value, and I'll circle right here, we start with that number. We have to convert meters to miles, but we also have to convert seconds to hours. And there are 2 conversion factors here. Now, I'll pause for a second. You can stop the video and see if you can do this on your own. Okay, and now I'm going to show you how this is done. And in fact, there are 2 conversion factors, one that will convert your meters to miles, and one that will convert your seconds to meters. Now, you'll notice, since seconds were on the bottom here, our conversion factor has to have seconds on the top to match it, and hours on the bottom. So if we have this, the seconds will cancel the seconds, the meters will cancel the meters, and all we'll be left with is miles on the top and hours on the bottom, and you can see that's what we get. And in fact, when you type 343 times 1 times 3600, and then divide that by 1, which you really don't have to do on a calculator, divide it by 1609, and divide it by 1, which again you don't have to do by the calculator, you will get this number here and more digits than that. I only showed you some of the ones that the calculator will show you. And then it also has a unit. These are the units that are remaining. Make sure you have the correct units. You can always cancel your units. If your units cancel properly and you get the unit you want, well, then there's a really good chance you did it the right way. Now look, we start with a number that has 3 sig figs, 343. the 1 really has infinite sig figs. So it's 343 meters about per exactly 1 second. And we have a number that has 4 sig figs, and then this number is exactly true, so that's infinite. So this is infinite sig figs, this is 4 sig figs, and our original number is 3 sig figs. Well, obviously 3 is less than 4 or infinity, so our answer must have 3 sig figs, and we round this number to 767 miles per hour. So we ask ourselves, does it make sense? Well, yes, it does, at least in terms of the unit. The unit certainly makes sense. Do the sig figs make sense? Yes, it should be 3, and this is 3 sig figs. And now ask yourself, does the number make sense? Well, this is a little harder to do with a complex computation like this. You might not be able to do this right away, but you can say, okay, 343 meters per second, and I'm changing a couple things, and 1 has a conversion factor that's about 4,000, and 1 has a conversion factor that's about 2,000 on the denominator, on the bottom. Well, 4,000 divided by 2,000 is about 2, so this whole number is around 2. So if we multiply this number by 2, we should get somewhere in the ballpark of 700. And sure enough, we do. So it does, in fact, make sense. Now, I don't expect all of you to have the math skills to do this sort of thing, but it is a skill that you can get when you estimate numbers that are in the calculation. This is around 4,000. This one's around 2,000. That's an easy conversion to make in your head, at least to simplify it. And then you can ask yourself, does this answer make sense? Also, make sure you type all these numbers in at least twice in your calculator. Here's another problem that's very similar, and I'm not going to go through the whole thing, but you'll notice the question says the density of water is 1.00 grams per centimeter cubed. Centimeter cubed, a cubic centimeter, or cc. You probably heard that if you've ever listened to a medical TV show, or if you're in the medical field itself. A cc is a cubic centimeter, or centimeter raised to the 3rd power, centimeter cubed. This is the exact same value as a milliliter. It is a thousandth of a liter. So these two things are the same. So grams per cc, grams per centimeter cubed, grams per mil, they mean exactly the same thing. But you're asked to convert this into pounds per cubic foot. Well, pounds is a unit of weight, grams is a unit of mass, but we have conversion factors for that because we know how mass relates to weight on Earth. We know about the gravity of Earth. So we have conversion factors for this. And in fact, here are your conversion factors. You're given the conversion factors. These can also be found in your conversion sheet if you ever look for them. And in your conversion sheet, you might have a conversion, and I just want to point this out on the side here. You might have something that says 1 hour equals 60 minutes, which equals 3,600 seconds, and I'm just giving you an example, and maybe that equals 7.549 x units, and then I'm just making up a unit. We'll call it xms. It's just a completely made-up unit. And what that means is I can take any two of these, or I can take these two, or any pair and divide one by the other. They don't have to be right next to each other. I know that 60 minutes equals 7.59 of these made-up units I have, and therefore that's a conversion factor. Or I know that 1 hour equals this, and I can put this over this, or I can put this over this, or any one of these, any pair of these can be made into their own conversion factor. So they don't have to be sitting right next to each other when you look at the conversion factor table. So we have these two conversion factors, and we need to convert grams to pounds, and we need to convert centimeters cubed to cubic feet, or feet cubed. And we have conversions for each of these. So I'm going to leave these to you to do the calculation. I'll pause it here, and you pause the video. And now I'm going to continue on and show you the answer. So you can work this out. Here's another one. How many times does a heart beat a year? So you're asked for beats per year. and you're given beats per minute. So in this case, you're starting with 72 beats per minute, and you were asked to convert this to some number of beats per year. So we don't have to change the beats. We only have to change the minute, so we're going to need some conversion factor that has minute on the top and year on the bottom. Unfortunately, we don't have a single conversion factor. This doesn't exist. Well, you might be able to find it on your conversion sheet. But you can create this by doing a number of things. You can take beats, and I'm just going to abbreviate it as B, per minute, and convert that to beats per hour, because you know how many minutes are in an hour. And you can convert beats per hour into beats per day, because you know there are 24 hours in a day. And then you can convert days to years, because you know how many days are in a year. Well, maybe you don't know the exact number. It's for the purposes of this, you could say 365 in a non-leap year. In a leap year, it would be 366. So since a leap year is every 4 years, we actually say that the length of a year is approximately 365.25 days. I may have a more exact value for you in your conversion factor, but in any case, you can do this by using 1, 2, 3 conversion factors in a series, and that's how you would get from beats per minute to beats per year. And I'm not going to do this for you. I'm going to leave this to you to try. I'm going to stop here for a second. You can pause it if you want to try it. And now I'm going to show you the answer, and you can see here's a series, and at the end you may need to convert this because you started with 72 beats. Now, I actually made a mistake here that I just realized. If the 72 is an approximate number, well, that's 2 significant figures, and in fact, this is the exact correct answer, 38 million beats per year, if the 72 is approximate. But if somebody counted exactly 72 beats, well, that's an exact number, and this is an exact number, this is an exact number, this is an estimated number with 5 sig figs, and this would be exact. So this is infinite sig figs, infinite sig figs, infinite sig figs. This is 5. So our answer in that case would be rounded to 5 significant figures, and we would get an answer of 37,868,000, and we would leave it at that, beats per year. But that's if we had counted exactly 72 as opposed to estimating 72. So counting 72 means this has infinite sig figs. Estimating 72 means it has 2 sig figs. And you need to know which of those situations it is to do it properly. I have assumed in this calculation that it was approximately 72, and I'm sorry, that it was approximately 72 beats, but I neglected to 72 in that case, if it's approximately, I'm sorry, let me move that for a second. So if the 72 is approximate, this becomes 2 sig figs, and 2 would be the least, and that's the number we would use here. So I know it's a little confusing. So if this is 2 sig figs, in other words, it's estimated, our answer should be in 2 sig figs. But if our number was counted exactly, that's infinite sig figs, and our limiting factor here is the 5 sig figs, and this would be our answer. I know that was a little confusing. And the last one involves a couple different conversions. The price of gasoline is $2.15 per gallon. Your car averages 32 miles per gallon. How far can you travel with $7 worth of gas? So the thing you have here is the $7 worth of gas. This is a conversion factor. You can see the per, so that's divided by 1 gallon. And you can see the rate here, the speed, is 32 miles per. Remember, per just means divided by gallon. So we have 2 conversion factors, this one, and we have an original value, and we're going to use the 2 conversion factors to calculate distance. And I'm not going to go through this one. I want you to try this one on your own. This is a little harder than I would ever give you on an exam, but if you could do this, you're in great shape. So here are more examples for you. 50 feet convert to centimeters, 28.25 days convert to seconds. You're given the conversion factors in your table, or some of these you know already. And I'm not going to work through the problems. I'm going to pause here for a second so you can pause the video. And now I'm going to just show you the answers one at a time. So you can stop the video at any point between these. And that is the end of this section. So we're going to start on density next.